to 7.4, which is on page 201.
Dang, I was way off.
What?
I swear I had the next quiz on there, dude.
What?
I swear I had the next. I zoomed in on it.
No. Well, what are you playing at?
And let me put this on.
I'm not doing that. Sure. Graham, you mean you want me to do this to the camera? No, he doesn't like him at all.
Ah, here we go.
Biology.
You did.
Biology.
Whoa! That. Hey, can we close the blinds?
No, we don't want to close the blinds.
Then I can't see.
What do you want to darken?
Yeah.
You want to open the blind?
Yeah. Can I see from
Well, you can see him.
Use some cell transport.
There's a terrible glare on your boat.
All right. The next thing we're going to talk about is how stuff moves around a cell. Stuff comes into a cell and leaves a cell. And it does this by a variety of methods. And the first one we're going to talk about is called diffusion. Diffusion is the normal way that particles move. They spread out. Particles tend to spread out. Did y'all know that? And it's because all particles are moving. All atoms have motion to them. And this is what gives them their temperature. Okay? All atoms are vibrating. Even look at your desk. The molecules in the desk, they're actually, they look still, but they're actually vibrating. And the faster the molecules vibrate, they're going like this. If you could see it at a really small, with a really good microscope, they don't even make microscopes good enough to see atoms. But if they did, you could see the molecules would be vibrating. And the faster they vibrate, the warmer the object is. And so because this object is not really, really cold, we know its molecules are vibrating. If there is no vibration, we have a name for that. Does anyone know it? If there's no vibration in molecules at all.
Absolute zero.
Absolute zero. And it's a temperature that's something like negative 273 degrees Celsius.
Gracious me.
Which is an impossible temperature to reach. It's just kind of a theoretical number because you can never stop the molecules from moving.
I can.
And it's because the molecules move that they naturally will spread out from one another. Imagine you had a bunch of pool balls on a table and they were all moving. They would bump into one another and they would spread out all over the table. They wouldn't stay together in the middle of the table if they were moving. They would spread out. And we call that natural spreading out that objects do. We call it diffusion.
So, if something's like on fire,
The molecules are really moving fast. Yeah. The hotter the temperature, the faster the molecular movement. That's always the case.
So are the atoms actually in the flames themselves, or are they in whatever is burning?
They're in the substance that's burning. The flames themselves are the energy, not the substance.
And something's frozen, they're moving like really slow.
That's correct. Moving slower, yeah. And it's a basic rule of thumb that every 10 degrees Celsius you go up, it doubles the molecular movement. So if something's 10 degrees hotter, it's moving twice as fast. 10 degrees Celsius, not Fahrenheit. 10 degrees Celsius is 20-something degrees Fahrenheit. I don't remember the exact version. Okay, so let's take a look at some videos of diffusion. Diffusion is just a normal spreading out that molecules do. Particles spreading out?
Molecular motion that occurs regardless of life, regardless of us.
Diffusion results from the random collision of molecules. In a natural search for more elbow room, they bump and shove each other from areas of high concentration to areas of lower concentration. Just as these collisions cause perfume or smoke to diffuse across a room, they can also push nutrients through any cell's membrane.
That's a membrane, can you tell?
Smaller molecules can move directly through the membrane
It's like a
as they
phospholipid
travel
to
from
me.
a higher concentration to a lower one. But larger molecules and ions can't slip through the membrane. Lucky for us and life itself, the cell can transport these materials in other ways. For example, some proteins in a cell's membrane act as channels for specific ions or molecules. These channel proteins don't use energy at all. They simply allow the materials to naturally diffuse from the side with more solutes to the side with less. Whether the direction is out or in depends on where the concentration is higher for each different solute.
Okay.
I almost got that movie yesterday.
Oh, I was watching.
So we say scientifically, we say diffusion is going from high concentration. You can see here we have some dye in a beaker. The dye is in high concentration here, and it spreads out and goes to lower concentration. So a high concentration is a lot of it in one spot, and it'll just spread out, and so it'll go from high concentration to low concentration. It goes in that direction, from high to low concentration. All molecules do this. And so that's the way some molecules get into cells. If they're small enough, they can go right through the membrane. So for instance, if you breathe oxygen and you take a lot of oxygen into your lungs, it will diffuse out of your lungs and into your cells into your bloodstream just by spreading out and moving out of your lungs, going from high concentration in your lungs, spreading out into your blood. And so that's diffusion. Odin, you with me? You look like you're zoned out.
That's diffusion.
What?
So you weren't paying attention.
What did he say?
Molecules dissolved in a solution are in constant random motion due to their kinetic energy. One result of this motion is that dissolved molecules become evenly distributed throughout the solution. This tendency of molecules to spread out is an example of diffusion. But how do these molecules come to be evenly distributed? Let's start with a beaker of plain water. What will happen if we now add a lump of sugar to the water? A lump of sugar is composed of many individual sugar molecules, and even as a solid lump, the individual sugar molecules are in motion. When the lump is dropped into the water, it begins to dissolve. Individual sugar molecules move randomly and constantly from the area where they are common to the area where they are scarce. This type of motion, when molecules move from areas of their higher concentration to areas of their lower concentration, is called diffusion. Diffusion continues until all the sugar molecules become evenly dispersed throughout the beaker. The rate of diffusion is affected by temperature, size of molecules, and the steepness of the concentration gradient. Although not specifically shown in this animation, this is one of the processes whereby materials are exchanged between a cell and its environment.
Now, what if the water were real hot? Do you think diffusion would happen faster or slower?
Faster.
Faster, because the molecules would be moving faster.
And if it was very, very cold,
It'd be really slow, wouldn't it?
Where's about to get hit?
One more diffusion video.
I said
What?
Uno mas.
No, por favor.
All molecules are in constant motion unless at absolute zero. The motion is random, with molecules moving in straight lines until they encounter other molecules. The net result of this process is diffusion, the movement of a substance from an area where it is in high concentration to an area where it is in low concentration.
That was an awful video.
That was terrible.
They got cut
That
off.
was probably the worst video I've ever seen.
That was one of the bad ones.
It was.
Okay, so in a cell, we see that particles can go from outside the cell to inside the cell. You see how the green molecules are in high concentration outside the cell and in relatively low concentration inside the cell?
Does that mean there's less of them?
That means there's less of them if it's a low
Then
concentration.
yes, I agree.
So there's a lot outside and there's not a lot inside. So they're going to tend to diffuse because they're small. See, they can get through the membrane if they're small enough. They'll diffuse inside the cell. They'll just spread out, and eventually they'll be inside. You see? Now, some particles are so big they can't get inside the cell just going through the membrane. So the membrane often has proteins, channel proteins. And the channel proteins form a hole that the big things can get through.
Awesome.
So here they are in high concentration outside, in low concentration inside.
No.
They can't get through the membrane, so they'll go through the channel proteins to get inside.
Sweet.
Yes?
Well, where do the other ones go? I think
The green ones?
no, if the number's getting smaller, are the channel protein like
The numbers of red things?
yeah.
Okay, there's a lot of them here and just a few of them here, so they're going to tend to go inside until the numbers are even everywhere.
Oh, okay.
Does that make sense?
And they use the channel protein as a door to get in.
Yeah, it's like a door. That's exactly what it's like. Uh-huh. You with me here, Drew?
The door
Yeah.
can't fit into a window.
Okay, you can't tell them. Now, there are such things as we call carrier proteins. Carrier proteins are proteins that have a certain shape. And they'll pull inside only molecules of the correct shape. See, the channel proteins are just holes that anything can go through. It's like a door. But the carrier proteins are like doors that only you have to have the right shape to go through. Channel proteins are like doormen, and they'll only let certain people in. They say, you, okay, you're good enough, you can come in. And another one, it might not let that through. So it has to have the right shape to get through a channel protein. I'm sorry, a carrier protein. And you can see it changing its shape to let it through. Video footage of this.
Some molecules, like water, can pass through the plasma membrane by simple diffusion. Facilitated diffusion occurs when materials are passively transported across the membrane using transport proteins. There are two ways this can happen. Channel proteins, a transport protein, forms channels that allow specific molecules to flow through. Carrier proteins, another type of transport protein, change shape to allow a substance to pass through the plasma membrane.
That was lame. It's not showing it change shape.
That was very lame.
That sucked.
I thought I had one that showed it changing shape, y'all.
So,
Hold on, let me go forward a little bit.
it's cool. Our blood cells look like donuts.
Yes, they do, Tucker. Good observation.
God, now
Okay, I'm gonna have to go to the AP Bio one.
Hey, Pro, are you doing that here in the bathroom?
Yeah, she can go to the bathroom.
Snap.
Dude.
Ah, Drew.
No, the video.
Now the video's gonna
My bad. No, I didn't mean to.
Yeah, it was Drew Love. Dude, look at that stain on
If
his
I was watching
butt.
that, I would have constantly.
Okay, AP Biology videos.
Yes, we hear the sound.
Oh, since we're here, can we watch the Element song? Maybe?
Yeah, while Drew's in the bathroom. Since we're
Yeah.
here. Yeah.
Okay.
AMG stuff.
Computers can do that?
What did he say? Computers can do that?
Good morning!
Why do the biologies not have cool
I
sound?
just haven't worked on it long enough.
That's awesome.
Okay, here shows some carrier proteins at work. No?
Does she still have her Jeep? She sold it for me.
Huh.
You never.
I might not have one.
You never told me this for sale. It's cool. Don't worry.
That'd be cool.
I just won't ever have a car.
This is carrier proteins.
Huh? I don't have anything. My parents.
Okay, here we go. All this for this. I hope you enjoy it.
There are two main types of transport proteins, channel proteins and carrier proteins. Channel proteins are tube-like and provide openings through which small, dissolved particles, especially ions, can diffuse. In general, each type of carrier protein has a shape that fits a specific molecule or ion. When the proper molecule binds with the protein, it changes shape and moves the molecule across the membrane.
See how that works?
That was so
That's one of the coolest things I've ever seen in my life.
See, I can make it go back and forth.
Like, go to the beginning.
And look how all the phospholipids are moving around.
I say watch it one more time. From the beginning, let's just get the whole experience.
There we go.
That's too fast.
I didn't catch a single thing out of all that.
What is that? There we go back to the.
Okay, now the next topic the book talks about is called osmosis.
That's not.
Osmosis is the diffusion of water, and we're going to do a little lab tomorrow where we do osmosis.
This is AP.
This is AP, but we can look at this. Here we have a case where we have two different solutions. This has this green solution that you see is high in water and low in solute. Do you know what solute is?
Do not.
It's the thing that you dissolve.
Solute is what dissolves. It's like sugar or salt or something like that. Okay? So this one has a lot of water and not much salt. Greater than 10% water. This one has less water and a lot of solute. So, oh wait a second. I think I'm showing the wrong picture. Okay, I'm sorry. Here we go. I messed up. This has the green one has a lot of solute, a lot of sugar. 10% sugar. And this one's only 5% solute, 5% sugar. And now what we've done here is we've taken, this is a tube by the way, it's called a thistle tube. And we've taken a membrane and we've stretched it over the bottom of the thistle tube here. And that membrane will not allow sugar molecules to go through it. It's impermeable to sugar molecules.
Is this an experiment?
Yeah, this is an experiment that can be done. We're going to do one similar to it tomorrow.
What's the membrane? What do we use?
The membrane looks like a plastic bag, but it has microscopic holes in it. And the holes are small enough are big enough to let water through, but not big enough to let sugars through.
That's some precise.
Yeah, it is. I'll show it to you tomorrow. It's called dialysis tubing. So what do you think is going to happen in this situation? This is high sugar, this is low sugar. Sugar cannot cross the membrane. Y'all got to use your brains here. If you're not paying attention, you're not going to be able to get this. Graham, you have your hand up.
I think I know what happened.
You think you know what's going to happen?
Could be wrong.
Come on.
What's going to happen?
I'm gonna go for it. I'm gonna say that all the water will come out of the green part, but the sugar will still be in there.
Water will come out of the green part,
But
and the sugar will stay.
I think that the water is going to dilute
Tucker says, say it again, Tuck.
the water is going to dilute the
Yeah, I'm thinking.
top.
The sugar.
So water will come from the beaker into the thistle tube?
Yes.
You think so? Why do you say that? You're right. Why do you say that?
Because there's no water in the green tube right
Because it's higher, it's denser.
Okay, so right now,
More
looking
dense.
at the percentages here,
Because I already saw the next one. That's why I knew.
is that why you're saying that? If you look at the percentages here, the percentage here is 10% solute, so it's 90% water. The percentage here is 5% solute, so it's 95% water. Where is the higher concentration of water?
The bottom.
Oh, in the
Here. So water is going to move from high concentration of water to low concentration of water. Water is going to move into the thistle tube. And will there be any evidence that water moves into the thistle tube?
Yeah,
Yes.
the top part will go up.
The top part will go up.
And overflow.
And we're going to do an experiment like that tomorrow. Aren't you excited?
I've been waiting for this my entire life.
That's what that
So look, see
not
the water
excited.
level goes up?
I am super excited.
OMG.
Oh my gosh. OML. Oh my lord.
JK.
I hate when people do that. They say it
Video
4 times. I
footage.
get
The movement of water is called osmosis. Video footage of osmosis.
JK.
Watch.
No, that was JK.
movement.
This membrane separates pure water on the left from a solution of sucrose and water on the right. The membrane is semi-permeable. Water can cross it, but sucrose is too large for the membrane's pores. Water molecules will move from a solution with a lower concentration of solutes to one with a higher concentration of solutes. A solution with fewer solutes has more water molecules that are...
Okay, that cut off, but
Can
the
water
point here is, see that, that's a sugar molecule, by the way. Those are sugar molecules, and they're too big to get across the membrane. But the water molecules can go right through it. So water is naturally going to go from where it's in high concentration over here to where it's in lower concentration over here. There's less water molecules on this side because sugar is taking up a lot of the space. So water will naturally spread out across the membrane from left to right. And the area on the right will expand because water is moving into it.
Can you
Pure
tighten
water
it?
go back.
It can't go back.
Turn the thing right.
It can't go
This?
back.
No, I think with your left hand.
But it won't.
But it'll overall, some molecules will just naturally
There we
go
go.
back because they're moving in all directions. But overall, there'll be more molecules going to the right than to the
To
left.
even it out.
Yes,
To even it out, exactly. We call the movement of water across a membrane osmosis.
Osmosis Jones.
Like Osmosis Jones, only totally not that because that's a character and this is a scientific process.
Yeah.
But
Love that.
What else
it is the same name. Have you ever heard somebody say, listen, Graham,
Sorry.
It's the fish movie.
have you ever heard somebody say they're learning something by osmosis?
Yes.
What they mean is they kind of put their head against it and the information
knowledge
just
can pass
flows
Is
into
Bro,
it.
does that work?
It doesn't work.
You sure?
Like sleeping on
Diffusion
top of
is
your
the
book.
net movement of molecules down a concentration gradient. This process allows small molecules, such as oxygen and carbon dioxide, to cross the plasma membrane.
Watch now, this is...
Most polar molecules, such as sugars and proteins, cannot freely cross this lipid membrane. Although water molecules are polar, they are...
Okay, so what they have here is a beaker. Let me just back this up a little bit. A beaker with a membrane separating the two sides of the beaker. Okay? And you're going to see they're going to set up an experiment, and I'm going to make you predict the results. So pay attention here. Sorry, I'm getting mail.
You got mail.
Terrible movie.
Although water molecules are polar, they are small enough to pass through the membrane freely. This special case of diffusion that involves the movement of water molecules across a membrane is called osmosis. If a molecule, such as urea, is added to one side of a membrane, it will not be able to diffuse across the membrane because it is both large and polar. Because of its polar nature, it will interact with other polar molecules such as the water. This interaction reduces the number of free water molecules on the right-hand side. With fewer free water molecules on the right-hand side, there is now a net movement of water molecules down their concentration.
I let it go too far. What's going to happen here?
They move to the
Since
right.
they're gonna move to the right.
And what will you
the
see
net
in the
movement of
beaker?
molecules.
What will you see in the beaker, though?
The water molecules be moving to the side that has the other polar molecules.
Oh, yeah, the right side water will go up and left side water will go down.
The right side, the water level will actually go up
large particles.
and be higher than the left side. This is what we're going to see tomorrow in the lab.
With fewer free water molecules on the right-hand side, there is now a net movement of water molecules down their concentration
See how it's
gradient
going up?
to the side with the urea molecules. Because more water molecules are moving into this area than are leaving, the water level on the right side will rise. If the osmotic concentrations of two solutions are equal, the solutions are isotonic. However, when the solutions have unequal osmotic concentrations, the solution with the higher concentration of solutes is hypertonic, and the solution with the lower concentration of solutes is hypotonic.
Okay, these are 3 words you need to know. Isotonic, hypertonic, hypotonic. 3 words, 3 choices, multiple choices, multiple choice tests.
What?
Now do you see?
So hypotonic is one with the least amount. Hypertonic is the
Let me teach you these words. Okay, here's a cell.
It's a cell that has lower concentration.
That's an animal cell, that's a
Solid.
plant cell.
Okay.
In this first case, there's the same amount of water outside the cell as inside the cell. Usually cells are about 70 or 80% water.
Cool.
So here's a cell in that's 80% water, sitting in 80% water, which is water that has a little bit of solute in it, maybe a little salt, maybe a little sugar. The same amount of water will go outside the cell as will come inside the cell because they're equal. And so we say there is no net movement of water in one direction. When we say net movement, we're talking about the overall, if you total up all the water coming in and all the water going out, it's about even. So these cells will not change. We say that the cells are in an isotonic solution. Iso means equal. So if the cells are sitting in an isotonic solution, they don't change. Okay? Now, let's put the cells in a hypotonic solution. A hypotonic solution is a solution that's very high in water, very low in solute.
Low concentration.
It's like putting a cell in 100% water, in pure water. What's going to happen here? Water's going to rush into the cell. Hang with me here, Drew. Water rushes into the cell, and the cell is going to swell up with water. And look, this one here explodes. Look at the stuff coming out the side of the cell. Oh, it blows up and dies. Look at this cell. It's a plant cell in a hypotonic solution. Water rushes in, the cell starts to swell up, but it's not going to explode and die. Do you know why?
Because the vacuole.
Because it likes pie.
It's got a tough cell wall. It's got a tough cell wall that prevents it from blowing up.
Made out of cellulose.
Animal cells don't have cell walls.
Made out of
Plant
cellulose.
cells do. Made out of cellulose, very good. True. So we call that a hypotonic solution. A hypotonic solution the cell is in. Now here's a cell in a hypertonic solution. A hypertonic solution, the cell will shrivel up. Water will rush out of the cell because there's a high concentration of water inside the cell and a low concentration of water outside the cell. It's like it's in really salty water.
The concentration.
This is why you don't water your plants with salt water. If you pour salt water on a plant, water will actually rush out of the plant and into the salt water that you just poured in.
Because there's less water.
And this plant will shrivel up. And so see the shriveled up cells? Look what a shriveled up plant cell looks like. We're going to do this in the lab. We're going to take a plant cell, it's onion cells, remember the same ones we looked at before, and we're going to put them in salt water. Instead of putting a drop of regular water on the slide, we put a drop of really salty water. And you'll see all the plant cells, the cell is shrinked up and is away from its cell wall and looks all shriveled.
Shrunk up.
Look how small the central water vacuole is.
Crow.
Yes.
I like stood in the ocean for a
Shriveled?
long period of
No,
time.
shriveled.
Well, your skin protects you
Okay.
from the salt water, but if you drank salt water,
Yes.
all your cells lose their water, and that can kill you. That's why you don't
See?
drink
See?
salt water.
That's why I hate the ocean.
Yeah. I'm sorry. Okay, I didn't know that.
I drink so much.
I drink it all the time.
Video footage of osmosis.
Let's see it, bro.
But then why do they tell you to? I'm sorry.
The leaves wilt because water diffuses out of the cell.
This is if you water with salt water.
The same thing happens to
Look at the onion cells. Do you recognize those?
Yep.
strong salt solution.
I don't see the unique ways.
Watch.
Oh my gosh.
Water diffuses from inside the cell to the outside.
This is scary music.
What's going on, bro? What's going
How
on?
long is this over?
A few minutes.
Now the salt water is being washed away by pure water, making the water concentration higher outside the cell than inside.
Going back because they put pure water on there.
The one in the middle is like Boomer.
What's going on?
Do we get to do that?
You could do that.
Water diffusing into cells
Not
creates
actually,
an
you
outward
can't.
pressure,
You can't do
which helps plants to remain stiff and upright.
Interesting.
You can't.
The problem that's
I mean,
sped
I'm
up.
pretty sure it's physically
so
impossible.
Why?
you wouldn't see it doing it that fast.
Do we have-
Yes.
Why do
Do
they
we have a
tell
work
you
to
to gargle with salt water then?
You know.
If you
Or
have,
if you have a sore throat.
this is a good question. If you have a sore throat, if you have a sore throat,
Or you get
the
your
cells
weight
are usually swollen up with water, and that causes pain. So if you gargle with salt water, it sucks the water out of the cells, and it doesn't hurt as much anymore.
Is that
Or
what
if,
Why does hot chocolate work? Why does hot
Or
chocolate
if you
work?
get your waist.
Because hot chocolate's got a lot of sugar in it.
Lot
Same
of-
with pickle juice?
And tea.
Same as pickle juice, same as tea.
So if you have a sore throat, you should eat some candy.
That would help. That's what cough drops are.
Just candy, just really bad.
Lots of
just candy.
sugar, and it sucks the water out, and it makes it hurt less.
Yeah, but then
Question? Yes.
Like a menthol kind of a
Don't get menthol, get fruity flavor.
No, no, you're not getting a whole bunch
Hey
of-
Drew, you just walked in front of the camera.
Video footage.
Oh.
Plants use water moving to open their flowers, to close. Look at it. Oh! Boom.
That was odd. Rewind for
To
the
raise their
camera.
leaves.
Can you rewind that Venus podcast?
Almost all plant movements.
So we gotta see that again.
The Godfather, that's a good movie.
Great movie.
Glad. Yeah.
Almost all